Yeah, so back to what we have been doing. So we are looking at this very problem, and the problem is to look forward the angle of B. Like I've told you, reference angle is the letter at the middle between two letters. The two letters happens to be the base arc um, angles, right? So these are the boundaries that are supporting the angle B. So once we hear, okay, well, once you have seen something like this, right? It means that what your reference angle is the lesser angle at the center, right? So now, where is angle B? Angle B is around this area. So where are the base angles that happens to be at this point, angle F and angle what E? So looking at this, if you can use your imagination and trace the lines, right? This is the line from F towards B, and this is the line from E towards B. So we are looking at this very shape, right? At this very angle. Do you get the point now? All right, so let's solve for angle B, right? So like in the previous videos, go back and watch the previous videos, I stated some angles theorems, supplementary theorems, which will really help us to solve this kind of problem. So in this case, number one frame we use is the area of semicircle that says that what angle in a semicircle sum up to what 90 degree angles in a semicircle sum up to 90 degrees. Now how can we know 90 degree semicircle angle? It's just like having something like this. I've shared this before in the next previous video, something like this. So gonna have, let me just say, a right angle triangle, right, in a circle, a right angle triangle in a circle. Now this makes up, this is a sign, or this just indicates what angle in a semicircle sum up to what 90 what degree. So in this case you can see that here around um EDB. So that's what we can see from all these sides. So we can see it around E, D, and B. So angle D is the real one that has this 90 degree, right? So that means in angle D, we are out of 90 actually. We have used what 66 degrees. So what's left is what 24 degrees. So this is how you can solve it. So let me show you how it's being done. So we have in triangle. Remind you, reference angle is D in triangle EDB equals to us 90 degrees. Then don't forget to put your theorems, angles in a semicircle, right? So we have angle in the semicircle, just a singular angle. So 90 degree equals to what angle in a what in a semicircle. So that's just what we have right there. All right. So now in this case, if you look at what we have out of 90, 66 degrees being used. So what are we gonna have? We're gonna have still triangle ADB, right, equals 90 degree, right? So let's split off still angle D as a reference. So let's split off this E angle or triangle EDB. Well, let's split it off into two sections. So we'll be looking at two things here. We'll be looking at this reference angle D between the boundary lines, the base arc angle of E and G, right? So that means that we're going to have something like this. Triangle EDB equals splitting off this angle into two. So we have angle D between what E and G. So we're gonna have angle what EDG, right? Next one, splitting off angle D into two. We're gonna have angle D reference angle between what G and B. Then we have plus angle GDB. Everything equals to what? 90 degrees. So I've stated this angle D between the boundary of what? Our boundary of what? A and B, right? To 2. So just the simple way to get this is just look at the reference angle, then between these boundary angles E and G, then same reference angle between boundary what? G and B. That would ideal that. So in this other angle, so we don't have the angle of D at the boundary of E and G. So let's put that one. So we're gonna have something like this. Say angle ADG plus Ice. Then the angle boundary, which is the reference angle, right, between G and B, right, happens to be what? 66 what degree. So let's have it as 66 degree equals to what? 90 degree. Right? So let's look at this angle D, right, between the boundary what? EG. That means we're gonna have something like angle EDG equals to what? 90 degree minus 66 degree. So we have what? Angle EDG equals to what? 24 degree. Now, you see, the thing is this, we're trying to solve for B. Then why are you going to the route of D, right? Now, what you always think about is you're going to make use of what is given to you. That's first extension. You are given 57 degree, you are given 68 degree. So how can you get angle B from these angles given to you? One good thing is this. Look into the theorems, all the theorems which have discussed in our last videos. Right, look into theorems and look at the um let me say the signs, right, that connects theorems which are relevant to your usage. Right, for instance, you're having kind of x kind of sign. So the x kind of sign is this at FE. The x kind of sign is at B and D, right? So that means that what we are looking at terms that says what angle in the same segment. So in that regard, you think, okay, what else can I, what can I get the value for this angle in the same segment? Definitely, we don't have any angle values around E and F, but we are having angle values around B and D. So the best one to use can be 57 because it's all between the tangent and the chord. So the best one to use to get the angles in the same segment, value for the angles in the segment is what? 66 degree. And 6 degree is found right in terms of what? Angle in a what? Semicircle. That reason why I have to go through this route to get the angle right in the same semicircle, in the same segment. I mean, in the same segment, you going through what the semicircle theorem, right? I'm getting the angle value for the same segment, angle in the same segment by going through what the angle in the semicircle. That is so. Now, what we have now is that what the angle here definitely will be what 24 degree, right? So that means that angle D, right, and angle B are angle the same what segment. So definitely angle B here will be what 24 degree. So that's how we can get the angle of B. So it's not necessarily that you have to look for angle in a straight line to get no. You have to look into the theorems. The theorem is going to tell you what to take or which road to take to solve a particular problem. And if you look at my previous video, angle D, right? Angle D segment, right? Their base arc angles have to be in the same mode. Now in the same place, I mean, okay, let's take this as the baseline for the angle, right? So look at this very well. Angle B actually has the B axis angles as well, E and F. So let's say angle, that is this reference angle and the center. So let's use angle what? E and F as the base angles with this reference angle. That is, we have angle E, B, F equals to angle. Now angle D has base arc angles, right? Base arc angles at E and F as well. Since they have the base arc angles, right? The same angle D shares the same base arc angle with angle B. So that means that what they are angled the same what segment. So we're gonna have angle EDF as well equals to what? 24 degree. Then mind you, you put your theorem there. You put your theorem there. That is angles in the same segments. So if you like my videos, please press the like button and subscribe for more by pressing the subscribe button. Do have a nice lovely day. Bye.